Really?
Yeah.
Cool.
Air gap jumping.
Obviously, it's not.
The neck.
Yeah, I know. Let's wait for these guys to clear out.
I'd like to welcome Patrick Orzechowski. His talk today is called Bridging the Air Gap Cross-Domain Solutions.
You're fine. So, can everyone hear me okay? Good? Yes? Okay. Speak up a little? Okay. There's no mic. So, before I get started, does anyone have any experience with CDSs that they want to admit to? Cool. At least one person. So a little background on myself as far as CDSs are concerned. I tested and audited and evaluated CDSs for an intelligence community customer for about 5 years. So that's where I'm coming from. That's my point of view with this talk. And the obligatory disclaimer slide. I'll let you read that. I won't read it. But the most important piece is no classified material is going to be discussed here. So what is a CDS? To talk about what a CDS is, first you have to define a classification domain. So you have, for example, secret, top secret, unclassified. And traditionally those networks have been air-gapped, right? So no logical connections between those networks. To transfer data from a producer of data to a consumer of data between classifications, people had to burn CDs, they had to use USB thumb drives, scan the data, and then move it to another classification domain, hence the term sneakernet. So for the years, the government did that. Post 9/11, they got the idea of using CDSs to connect different classification domains, different agencies together. And the definition of a CDS to me is the connection of two distinct classification domains. So secret to top secret, unclassified to secret, unclassified to top secret. So you might think it's a firewall or just a filter. No, it has some distinctions. SE Linux or Trusted Solaris, it'll label the data coming in on either side. So packets will be labeled as secret, top secret, unclassified, and those are distinct separate domains on the system. It uses mandatory access controls. So no discretionary access controls. The access controls are set by the system. Even system administrators cannot change access controls. And type in data-driven security. This is important because it understands the data that's flowing through the box, right? So not only are you allowing just a port and protocol, you're allowing, and it's available to be leaked. I don't know, but it's probably a good idea to protect some of this critical infrastructure with something like a CDS, an enclave. Might help here too. If I built a system to protect my citizens from rockets falling down on their head, I probably don't want that information to get in the hands of my adversaries. So making sure that data that's critical is not flowing through your network is important. Some examples of CDS: data flow proxy, push-pull, and one-way transfer. And I'll go through each. Quickly, data flow and proxy, you'll have a TCP connection on either side or UDP connection on either side. You're actually connecting to the CDS, the guard. Push-pull is a pretty cool paradigm. It acts as a client on both sides, or one side or the other, right? So we'll look at that. And one-way transfer is basically one-way fiber transfer to get data into a network, but data cannot flow out. So this is an example of data flow. This is a company, Cybard. They're from the UK actually, so US isn't the only ones that make cross-domain solutions. They built a guard that does XML, and you can see not only does it understand that XML is flowing through, it does all these checks as the data flows through. It does a virus check, schema, embedded content. That's what I just talked about. It actually knows the tags that are flowing through it, right? A whitelist of tags, XML tags that are flowing through it. And it understands the embedded content within those tags. So if it's supposed to be a 10-digit integer, that's all that can flow through it. If it's 9 digits, if it's ASCII text, it'll drop that traffic. And all sorts of other things, a sig check, label checking, transform, normalize. Transform and normalize would probably be something like data scrubbing. So if there's a dirty word in there, an acronym that's classified, it might drop that. Push-pull, this is an interesting example because the CDS here acts as a client only. So it'll go out to file servers on the unclassified side and the secret side in this example, and just push and pull files and act as a client. You can have hardware or software firewalls on either side. So let's say the unclassified side gets compromised by attackers and they do a scan of your network, they're not going to see this CDS. It's going to be a MAC address only on the switch, right? The only way that they would be able to get into this enclave is to compromise this file server and see that some weird system is actually connecting and pulling data, which is a pretty interesting and cool way to hide and black hole your CDS from the bad guys. One-way CDS is pretty simple. This is called the Fox data diode. This has transmit and receive on the black side, and on the red side you have a one-way fiber transfer. So transmit on the data diode and receive only on the red proxy server over here. So it's connected only one way with fiber, so it physically cannot transfer data back through to the unclassified side. And this is a really good way to pull data from the internet, from unclassified networks, NTP data, GPS data, for example, or if you're mining social networks or monitoring people on the internet, this is a good way to flow data back into your classified side for analysis, right? Take a drink of water here. Sorry, my mouth is getting dry. So some pros. Cost, right? You don't have to pay the guy to burn CDs and transfer data between your classification domains anymore. Data sharing. You can share data between classification domains, between agencies on a more quicker basis. Make it more available. Internet data. You can pull data from the internet into your classified systems without actually worrying about data reversing out. Power and cooling is another example I thought of. Raytheon makes a product, a thin client, where a CDS sits in the middle and they can actually virtualize desktops from different classification domains. So if a guy has 6 different workstations under his desk, you can actually collapse that into one thin client. And if you've ever been at a government facility, a lot of guys have secret, top secret, unclassified workstations all over the place. If you can collapse those, you save on power and cooling. Some cons. Cost is a con too, right? If the more complex the system, a data flow system, for example, the more it's going to cost for those experts to come in and configure that for you. Availability. If your CDS goes down, if your data center is taken out, do you have the ability to come back and institute that sneaker net? If you fired that guy that you didn't need anymore, right? Vulnerabilities and complexity kind of go hand in hand. These systems are built mostly using open source, COTS products, that kind of stuff. So it's really scary to think that you're introducing a connection where there wasn't a connection before on an air-gapped network with potentially vulnerable software. And complexity, the more systems you connect together, the more chances there are you might misconfigure it, right? And data might flow the wrong way, or you leave a hole open, and the bad guys can get in. Some examples of COTS products, Raytheon's High-Speed Guard, Boeing Hardware Wall, TCS Trusted Guard. These guys got bought by Raytheon, I think, and Northrop Grumman, SmartNext, which is an email classification filter, so you can send emails between classification domains. There are dozens of these. I put these up here because there's a theme here, right? These are government contractors. These aren't software companies. So oftentimes they'll build these systems on, like I said, COTS and open source products, and their focus isn't software building. So it's kind of scary to me a little bit. This is Boeing's hardware wall. This is right off their site. You'll see here different classification domains: top secret, secret, unclassified, and within those are different compartments. And this is hard to see, I know, but I put this in here because I wanted to show how complex these systems can get very quickly. Theoretically, you have unclassified internet down here, and you have top secret SCI compartments up here. And they're connected via the same box, right? So any vulnerability in the system, any SE Linux vulnerabilities or vulnerabilities introduced by a misconfigured policy or software would allow an attacker to jump from here to here, right? And that's a bad thing. The MDEX system, I ran across this. This was a new one to me. They were nice enough to share exactly what software they use to build their CDS on their website. And I don't think I would run Oracle Java on my CDS. I wouldn't run MySQL and Splunk on my CDS. Those are traditionally vulnerable COTS products that if you're trying to separate classification levels and you're protecting critical data, critical infrastructure, it's a bad day. This was another new one to me. These guys hit me up on Twitter, and they told me to check out their product when they saw that I was doing this talk. And I asked them, I said, so you're using SE Linux, Trusted Solaris, what's your trusted platform underneath your CDS? And they responded, I'm going to quote here, it uses algebraic modeling for new implementation of trustworthy computing. SE Linux Trusted Solaris equivalent but usable. And my vaporware meter kind of spiked a little there. They have some smart guys working for them, but if I was going to build a CDS, I'd probably use a known trusted platform, right? So what do you look for when you're testing these things? It's similar to testing commercial networks, commercial products. Think like an attacker. Data exfiltration. Confidentiality is key. That's the #1 of the CIA triad when you're looking at CDSs. You're trying to keep the data confidential on the one side. Remote command and control. Is there a way to shovel a TCP reverse shell through a CDS to command and control a classified network? One that controls drones, for example, or one that controls the submarine networks. The possibilities are endless because these things are deployed everywhere. Data integrity. Can you send an authenticated message through a CDS that could potentially be misconstrued as an actual message telling people to do things like sink a ship? Data exfiltration, similar exfil techniques for DLP. How do you get through those strongly typed XML fields? Can you encode the data, right? You might know that it takes a 10-digit number, but can you encode data within that to exfil classified data from top secret to secret? Some other things off the top of my head, TCP options, you can encode data there, IPv6 headers, HTTP headers, regular data encoding, base 64 encoding. If you're not looking for that, it'll pass through your CDS and potentially get out. Steganography, if you're passing imagery data, people can hide stuff in there, right? So what's different about testing a CDS? Every control is relevant, right? And if you ever have done certification accreditation on government systems, the more controls, the harder it is to pass it, the harder it is to actually test it. And when you're looking at something like NIST 800, there's 600 plus controls that are applicable to these systems. So it makes it really tough, really challenging to test these systems. You might have competing agencies, right? You might have the FBI on one side of a CDS and the NSA on the other. They have completely different ideas about how they want to secure their systems, right? And it creates a whole political firestorm, and it makes it difficult. Non-traditional. So what I mean by that is the old school govies don't want to connect secret and top secret or different classification domains. They don't get the warm and fuzzy seeing an actual connection between these two networks, right? So you kind of have to not do a little bit of smoke and mirrors, but give them the warm and fuzzy that these systems are actually secure and built with a trustworthy platform, right? And there's common criteria, and the folks that know how to test these systems kind of build the executive reports so people understand that they're taking due diligence. The government saw fit to build a unified cross-domain management office. So this website went online, according to archive.org, about 2007, and they went offline in 2013. So I'm not sure what happened to this office. Hopefully they didn't get budget cuts or sequestration or any of that, because I think it's really important to have one overarching office oversee these cross-domain solutions, right? Otherwise, each agency, each compartment is handling their own business. And they had an approved products list, and they had a set of controls to test cross-domain solutions against, and now they're gone. But there's still a bunch of data on archive.org. I've got a link in my links to that. Some commercial uses. SCADA. I know the data diodes and one-way transfer systems are starting to protect networks. Utilities, that kind of stuff. Finance, IP vaults, forensics networks. I'm thinking if you could tell a judge that there's no way data can get out of your forensics network, that you're keeping that data safe, potentially. It's kind of like a write blocker on the network. Transportation systems. I'd like to know that trains and planes and cars are being protected by systems that are strongly typed, that are whitelisting instead of blacklisting, which is what most people are relying on nowadays, unfortunately. Some challenges, I kind of talked about these before. Binary data. If you have images flowing through your CDS, how do you know if that's classified? You kind of need a set of human eyes on that to say, hey, this is a satellite image that shouldn't pass through. And then maybe put some XML metadata on that image. Encryption, if you don't have the keys, you can't see what it is. So it'll flow right through. Speed and RFCs, you kind of see with commercial proxies as well. The more you inspect the traffic as it flows through, the slower it gets because more CPU cycles, that kind of thing. RFCs, different developers have different ideas of how to implement protocols. So these CDSs break things often. Data classification. And this one's kind of near and dear to me because people tend to overclassify their data. They tend to think that their data is way more classified than it actually is. And if people would classify their data correctly, it would eliminate the need for these cross-domain solutions. It would eliminate the need for secrecy, and maybe we could have a little bit more transparency. Serious concerns, aka what keeps me up at night. These systems are developed and configured on unclassified networks. So what's to say you're not downloading a package that's Trojan when you're using open source software to build a CDS? That leads to the chicken or egg problem. Once you plug a CDS into a highly classified network, it takes that classification. It automatically becomes that highest classification. And you run into the chicken or egg problem, and I just talked about that. Reciprocity is a term that people use for evaluating products, like say a Juniper firewall. Once it's evaluated at a certain level, then it can be deployed without actual testing. And because these are built specifically for certain programs, projects, and protocols, they need to be tested individually. You can't just say, well, I bought a Boeing hardware wall and I'm going to plug it in and I don't need to test it or pen test it because it's been tested against that level before. The idea of a crossover process. So with trusted computing, you have to have something when you're transferring data to actually transfer the data between the highly sensitive side and the unclassified side. And this is your trusted process. This is the process that actually transfers data. It's the equivalent of the guy that burns CDs and transfers them back and forth. So what's to say there's no vulnerabilities? Who's looking at the source code of these crossover processes that are being built on different guards? There could be vulnerabilities. Maybe people have found vulnerabilities in these that allow data to flow the wrong way, for example. And this is, I think, this came from PostgreSQL, Security Enhanced PostgreSQL, which is a cross-domain kind of RDBMS. Some takeaways from the talk. CDSs need to be tested and tested and tested. Find some smart pen testers to go in and try and hack these things because they're protecting our most secret and important classified networks. No more air-gapped networks. I don't think there really are any more air-gapped networks. Unless it's so legacy that it doesn't support TCP/IP, there aren't any more air gaps. Whether it's 6 degrees of separation or 60 degrees of separation, somewhere down the line, everything is connected to the internet, which is a scary, scary thought to me. De facto builds, operating systems, COTS products should be scrutinized. Open source, right? We saw with OpenSSL. That was considered a trusted platform and is used all over the place and had a serious, serious bug. No more UCDMO. I'm assuming this, and it's scary if there aren't any more management office to actually oversee the approved products list for these CDSs. Access control, take it out of the user's hands. Don't let users set access controls for critical files and critical infrastructure. Discretionary access controls are dead. Don't use them anymore. Start using SE/Linux. Future project, potentially OpenCDS, open source cross-domain solution, distro, that would simulate what I've seen in my experience. And it would be for testing purposes only, obviously, and built using Trace's tools, open source tools that they have for building SE/Linux policies and things like that. If anyone's an SE/Linux expert and wants to help me with that, maybe you can hit me up on Twitter. So any links, references are on this Tumblr. I posted them yesterday. Special thanks to Phil, my mentor, and BSides for having the mentor track. This wasn't a very popular talk, but it was cool to give it. And thanks to my wife and my mom who will find this video, no matter how obscure it may be. That's my contact info. And any questions?
You had said that they can get data into the private network. So does that mean they can get HTTP requests or only if someone downloaded it to the network?
Are you talking about one way?
Yeah, you have the one way.
Sure.
Yeah, that one.
So this only allows data into the network. So you'd have to use something connectionless like UDP to shovel data across.
So you have to like download the file you wanted, put it on the proxy.
Yep, put it on this proxy server, and then it would shovel it via one-way transfer over here. That's a good question. Yeah, no TCP connections here because you don't have a reverse fiber to allow that, SYN, SYN-ACK, ACK transfer there. Good question. Yeah. I mean, theoretically, anyone could purchase one and implement it. I've never seen a commercially implemented CDS. I know friends that have worked in utilities and things like that said that these things are being sold to them as kind of not a silver bullet, but a way to protect their SCADA networks without implementing a whole bunch of other controls. Thanks. Good question. Go ahead.
I just wanted to say thanks for this talk because probably around 4 years ago I was a student employee and I was working on one of these.
Mm-hmm.
And I had no idea there was like a greater concept of the system. I didn't even know, I wasn't on the inside of that. It's just interesting we were working on XML
Cool.
filter systems
And
that sort of thing. And I was,
did you know how critical the systems you were working on?
I mean, I knew what the implementation was, but I didn't have any access to who the customer really was and that sort of thing. But like,
Was anyone looking at your source code?
C Linux policy was my first software job.
Cool.
So what do you think is the biggest obstacle to a wider acceptance of mandatory access control?
Lack of knowledge. SE Linux is that thing you turn off.
SE Linux isn't mandatory access control. It implements that.
Yeah.
Are separate from SE Linux. So acceptance of mandatory access control of other systems as well. Why aren't we seeing them when you can do so much with them?
I don't know. That's a really good question. I think,
They're really cool.
I hate to say it because I'm a sysadmin myself, but I think sysadmins keep that discretionary control, right? They want to keep that root over the whole system, and they don't want to give up their role as God. I think that might be a part of it. But yeah, I don't know. It's hard. Is a simple answer, right? It's really hard to implement mandatory access controls. It takes time and knowledge, right? So you can't just flip a switch and have it. And tradition, right? I don't know. What do you think?
I don't know. I mean, you look at all of these guides for configuring systems, and they don't assume mandatory. And now, there are ACLs, which are kind of
Sure.
people do things kind of with ACLs, but mandatory access controls and ACLs are not the same thing.
Yeah. Okay. Yeah, I don't know. So I think I'm out of time, but if anyone wants to talk, we can go to the chill out room and talk. Thanks for your time. I appreciate it. I know it's late in the day.